Let's start with my presentation. With the outline, I will first talk a little bit about the packagings and the products that we are talking about. The compounds, the mineral oil contaminants, this is a very complicated class of compounds, and I will show them to you. The next will be something about the limit values, but there we will have a later presentation which will be more specific about that. Mainly, the main thing we have to think about is the transport mechanism of the mineral oil contaminants. How are they transported in practice? And how, and this is the title of my presentation, how can we avoid this? And this is more tricky than one usually thinks. And to have an idea on how these mineral oil residues can be avoided, we have to talk about barrier materials, and I will show you just two investigations we did to show how these barrier materials perform, and some conclusions at the end. So first, this is where which kind of packaging materials are affected and where they are located. We first have corrugated cardboard boxes as transport packagings, but we also have sales packagings from recycled paper, and those may be either with an inner pouch, this is also very common, or in some areas we will have just also no pouch at all. We just have the recycled paper for a few kind of products. In the end, when these have been placed into the transport packaging and the transport packaging has been placed again on a pallet, we usually have the pallet wrapping, which also influences the final result, namely the transport of contaminants. We call them MOSHs and MOAs, and I will show you in a minute what they are. And they are, in the end, and that is something we in the end do not want to have, some of them end up in the product. And therefore, we have to look for a remedy about that. Mainly, what is affected, we have those paper and cardboard-based product packagings. Those product packagings may have a permeable inner bag, like this one, like for instance, rice for boiling, but it may also have nothing at all in this context. If you have an impermeable bag, you are on the safe side in most cases, so I don't want to talk about this. We also have the transport packagings, and also their contamination may be transferred into the products. This is also very important. And in total, we are talking about much more than 10 million tons of recycled paper, which is affected by these considerations in Europe. So just to talk about the areas of products we are talking about. This is a simple presentation on which kind of barrier is needed for which kind of food, and this deals with the sensitive foods. So this is the water vapor transmission rate, this is the oxygen permeability, and this shows that we have a relatively interesting area of sensitive foods which need a high barrier, and we have not so many foods that need no barrier at all or only a low barrier. Just to break that down into the area of paper packaging, we have one area of foods that have don't have any barrier at all, don't need any barrier at all. So, but this is only a very small minority. We have some intermediate sensitive products which can be protected by paper or cardboard together with a polymer. But you see that also these are not covering the most sensitive area of food. And we have the paper and cardboard with aluminum, which is nearly a perfect barrier in spite of the holes and defects you get upon sealing. I will talk mainly about these because this is no problem for us. Okay, then let's look a little bit more in detail. We are talking about sales packagings because the product is in there. They may have more than 3 different layers in the case of aluminum foil-based packagings. And here we hardly have any problem at all. The only problem we have is the so-called set-off, which is the contact when the rear part of the package contacts the product side, but this is much less than the rest. We have other packagings with about 2 different layers, for instance, laminated pouches or boxes where paper and board is laminated to polymer films. It can be coated to polymer films by extrusion coating or by blade coating. And we can also have cardboard boxes where we have an extra interior pouch, which is also very popular. So all these are used for less sensitive products, but because they are used for less sensitive products, they also have a lower barrier, and therefore they are more relevant for mineral oil residues because they may permeate through the through the package and therefore contaminate the product inside. We may also have sales packaging from monomaterials, recycled paper, and this is only for very insensitive products which practically don't need any barrier at all, but also those products are very sensitive against the transfer of mineral oil residues. And finally, there's the transport packagings, the boxes where the primary packagings are usually transported in. And also from there, and especially from there, we may get mineral oil residues because most of these transport packagings are made from recycled paper. Okay, then the next point is, where are we talking about when we talk about those mineral oil residues? We are talking about so-called MOSHs, that are the mineral oil saturated hydrocarbons. Today, people are more or less all saying that they have a relatively low toxicological relevance. But we are also talking about the mineral oil aromatic hydrocarbons. And if you see the word aromatic, you already recognize that some of them may be cancerogenous or have other adverse properties. And therefore, this is the fraction that has the highest toxicological relevance. We also have some olefins or hydrocarbons from other sources. Some may come from the polymers. We call them POSHs, the polyolefin saturated hydrocarbons. They are also saturated and have low toxicological relevance as well as the polyalpha olefins. So this is our main concern. To talk about the number of compounds we have, this is from an EFSA journal. You see that if, for instance, if you have 10 carbon atoms, you already have between 100 and 1,000 different compounds. And if you come to 14 carbon atoms, you already have 10 by the power of 5. And you may even have, for higher amount of carbon atoms, you have millions of different compounds that you have in your residues. Some spectra to show about the problems we have to identify and even measure them. This is a GC spectrum with some distinct substances and a big so-called hump, which is a mixture of all other smaller amounts of different substances of this group. This is what we see in the product. This is what we see in the board. So some of this, what has been in the board before, is being transferred to the product in this case. This is already a relatively old investigation, but it still shows the problem very well. We have the moshs here and we have the moas here. They may be separated. You see that moas are less than moshs, but they appear in the product once again. And here you see the nature of those compounds, the alkanes, the naphtines, which are still saturated hydrocarbons, and we have the aromatics, which are non-saturated hydrocarbons, which much more negative influences on the human health. Okay, some interim conclusions. We have the problem with those mixtures of a large number of substances, which makes things complicated, especially when measuring them. I showed you these humps, which create the problems in measurement. The substances have a different size. Some are small, some are large, and therefore their transport properties are there, but they are different, and therefore they may also separate, and you may have a different composition in one compartment compared to the other. Therefore, you cannot use just something like we are doing with the polymers, where you say, okay, I have a number of about 1,000 allowed substances and I can measure what is in there. This is not possible here. And therefore, to measure something, which I will show you later, to do this, you need so-called reference substances to have an idea what will happen in the practice. Okay, the limit values, I think Fatima will talk a little bit more about this. I will only give some examples. This is from the EU Commission, showing that the mineral oil aromatic hydrocarbons should be less than 0.5 milligrams per kilogram in the ready packed food up to the shelf life. And the more fat is inside, the higher is the allowed amount of contamination. This is different in Germany because this is not regulated on an EU basis. Here we have the same amount of 0.5 milligrams per kilogram, but valid for any food. And if you measure not with food, but with a so-called simulant, which may be, for instance, water ethanol solutions, the limit of detection is lowered to 0.15 milligram. So it's already something that is very tricky talking about the analysis of this. The French have another order limiting the amount of MOAs within printing inks. And these are printing inks to be used for food packaging purposes, not the other printing inks where we make recycled, where the paper is used, we make recycled paper of, for instance, newspapers. So they limited this and they are going to limit it further down and down to a limit where I must say it will be really tricky to measure this. But you know, the law is somewhat, in some cases, different from that what is technically possible. Overall, we can say that we have a different way to assess the relevance of the mineral oil residues, and it belongs still on the legislation of the individual country. Okay, then the question is, what is really happening in the practice? And this is a schematic presentation of what is in such a packaging system. You usually have everything on a pallet. You have a wrapping on the outer side. You have the transport packaging. You have a sales packaging. In this case, it's from paper and board, recycled paper and board, but maybe also fresh virgin fiber paper and board. We may have a coating or an inner liner, and then we have the product. And the problem is that most of the contaminants come from the transport packaging. They are transported from the packaging through the air, again into the other packaging, through a polymeric barrier, and they end up in the product. They are hindered to evaporate into the environment, partly hindered by the pellet wrapping. And so we have to talk and think about all these different steps and to understand where most of the contaminants come from. This is here. And what can help against this? And this is the barrier. It should not have leaks, by the way. And what we also have to think about is if we have everything on a roll, we have the so-called set-off, where the outer side of the packaging gets in contact with the inner side of the packaging before the final packaging is being made. Okay, so main question, how can the uptake be prevented? And our German authorities already made some statements about that. They said that it can be prevented through the use of virgin fiber cartons, mineral oil-free printing inks. You see already the French ordinance behind this, or the inclusion of functional barriers in the packaging structure. And you should think about the transfer from secondary packaging. That's all true. And the question what we have to put up now is what helps us really and what has only a low chance. And the point is the primary package, if you look to virgin fiber package cartons, it gives only a low chance against the transport of substances from the transport packaging, because the transport packaging still is not made from virgin fiber cartons, but from recycled paper containing those mineral oil residues. Also, if you think about mineral oil-free printing inks for food packaging, this is good, but it does not help about the mineral oil residues from the recycled paper in the transport packagings. So in the end, one must say, if you would like to be sure to avoid this contamination, you need functional barriers in the packaging structure. And this can be done by sealed inner pouches, which gives the best option, but is also not very environmentally friendly because you are using extra material, which you in many cases don't like. You can use extrusion-coated layers or laminated layers. Laminated layers are a bit better than extrusion-coated layers, but both have risk of damage, and at the cut edges, you have a problem of transport of substances. And wet coating of cardboard can also be done, but this has an even higher risk of damage and therefore is the third in this row. Okay, this looks a bit confusing, but I will help you a little bit to understand what is meant. We tested different polymers, which are shown here. with respect to their barrier against different model substances. They go from 12 to 24 carbon atoms. And you can see that the polyolefins, cast polypropylene, biaxial-oriented polypropylene, or high-density polyethylene are very poor barriers against this. And if you compare them with really good barriers like PET, you see, for instance, for the smaller molecules, a difference or a factor of nearly 6 orders of magnitude in terms of barrier. So this tells you already that you should be very careful to select the barrier materials. And if you ask me, why don't you find PELD in this presentation? The reason is quite simple. PELD is even worse, and it's basically not at all a good barrier for this kind of material. So if you would like to use a coating or an extra layer or something like that, you should more look into this area here than relying on PE coatings or PE inner pouches. Acrylic and EVOH is in between. EVOH is a good oxygen barrier, but less good for the mineral oil residues. Okay, I'm close to the end, and I would like to confront you with a lot of conclusions in my summary. We can say that in the packaging sector, the mineral oil residues are found in recycled papers. This is an important area of the economy, that's for sure. So we cannot simply ignore that. We have a majority of the recycled paper in transport packagings for corrugated cardboard boxes. But what I said to you is that this can be there, the residues can be transferred through the product packagings into the product package. Therefore, we have to look for the sources of these residues. And these are solvents from printing inks, but not mainly from the printing inks for the product packagings, but printing inks from, let's say, newspapers and similar products that end up in the paper recycling. And then it's transferred. We have the mineral oil aromatic hydrocarbons, which are the critical factor. And therefore, this kind of substances is usually transferred to the food packed in the paper or cardboard packagings if you do not do anything against this. But even with a barrier coating, you may have the problem of set-off. You have to look for this as well. And therefore, the best strategy, but also the most ineffective strategy is to use separate bags because they give their own barriers and make the problems very small. The barrier coating on the inside of the primary package is less safe, but it can be used as well. And if you use polymers as barrier materials, you must look very closely to the type of the polymer. In this case, you should choose PET, polyamide, or EVOH because they are the best barriers. You can use aluminum foil as well, that's for sure, but this is something that's, yes, I would say a bit over-engineered. And finally, polyethylene and also polypropylene are no good barriers at all against this kind of substances and therefore should not be used. So that's it. Thank you very much, and I hope I still kept the time.